Welcome back to the real number system. In this video, we're going to focus on dividing rational numbers. So let's get started. One way that we can illustrate division is by using the area model. So let's suppose we want to know how many halves are in 3 wholes. To illustrate this, I draw 3 circles to represent my 3 wholes. I want to know how many halves are in the wholes, so I divide each circle in half, and I'm going to count how many halves we have. Notice there are 6 halves in 3 wholes. Let's look at another one. I want to know here how many eighths are in 3/4. Draw a circle, divide your circle into 4 parts, and then we're going to shade 3 of those parts. Now, if I divide each quarter in half, that gives me eighths. And then I'm going to count how many eighths I have in the shaded portion. Notice there are 6 eighths in the shaded portion, and so my answer here is 6. Remember, our definition for division is we can divide 2 numbers, say A divided by B equals C, if and only if C times B equals A. The same is true for our rational numbers. So A over B divided by C over D equals E over F. If and only if I can multiply E over F and C over D, and my answer is A over B. Our algorithm for division is this. We bring down that first fraction. Then we change our division to multiplication, and we write the reciprocal of the second fraction. In other words, we invert and multiply. A radio station provides 36 minutes for public service announcements for every 24 hours of broadcasting. In Part A, we want to know what part or what fraction of the day is allotted to public service announcements. So first, I need to be sure I have the same units. We have 36 minutes and 24 hours. So I want to change my 24 hours to minutes. There are 60 minutes in an hour times 24 hours gives us 1,440 minutes. Then second, I look at my fraction. The part of the day that's allotted for public service announcements is 36 minutes, divided by 1,440 minutes total. Simplify your fraction. 12 goes into 36 3 times, and 12 goes into 1,440 120 times. This fraction will simplify further. 3 goes into itself 1 time, and 3 goes into 120 40 times. And so our answer is 1/40 of the day. Look at Part B. How many 3/4 minute public service announcements can be allowed in the 36 minutes that are allotted during the day? In other words, I'm taking that 36 minutes and I'm dividing it into 3/4 minute segments. Our rule for division is we bring down the first fraction. I can write 36 as 36 over 1, change division to multiplication, and write the reciprocal of the second fraction. So the reciprocal of 3/4 is 4/3. And then multiply. Now here, I like to simplify first and then multiply. Remember, we can only simplify from top to bottom. 3 goes into itself 1 time, and 3 goes into 36 12 times. Multiply the numerators. 12 times 4 is 48. And multiply the denominators. 1 times 1 is 1. 48 over 1 tells us there are 48 public service announcements in the day. Look at the next example. We have 35.5 yards of material available to make towels. Each towel requires 3/8 yards of material. I want to know how many towels can be made. So I'm taking my 35.5 yards and I'm dividing it into 3/8 yards each because each towel requires 3/8 yards. Change your mixed number to an improper fraction. Our whole is 35. The whole is divided into 2 parts, so multiply times 2 And we have one more part, divided by 2. 35 times 2 is 70, plus 1 is 71 over 2. So 35 and 1/2 is the same as 71 over 2. Change your division to multiplication and flip your second fraction. The reciprocal of 3/8 is 8/3. Again, I like to simplify before I multiply. We can only simplify from top to bottom. 2 goes into itself 1 time, and 2 goes into 8 4 times. Multiply your numerators. 71 times 4 is 284, and 1 times 3 is 3. Now we want to know how many towels can be made, so I'm going to divide 3 into 284. 3 goes into 284 94 times. It means I have 94 holes. So that tells me we can make 94 towels. Look at part B. Part B asks us how much material will be left over. Well, first, I need to know how much material I used. Each towel used 3/8 yard, and we made 94 towels. So I'm going to multiply by 94, or 94 over 1. Simplify before you multiply. 2 goes into 8 4 times, and 2 goes into 94 47 times. 3 times 47 is 141. Multiply the denominators. 4 times 1 is 4. Then second, I'm going to subtract my total material I started with minus the material I used. The 35.5 yards minus we used 141 over 4 yards. Change your mixed number to an improper fraction. In part A, we saw that 35.5 is the same thing as 71/2. Bring down your second fraction. Find your common denominator, which is 4. Write each fraction using that common denominator. 2 times 2 would make 4 in the first denominator. If we multiply the denominator by 2, we also have to multiply the numerator by 2. 71 times 2 is 142. The second fraction already has the denominator 4, so bring down the numerator of 141. And when I subtract, I get 1/4. So 1/4 yards of material would be left. Look at example 12. A bookstore has a shelf that is 37.5 inches long. Each book that is to be placed on the shelf is 1¼ inches thick. How many books can be placed on the shelf? In other words, we're dividing 37.5 by 1 1/4. First, change your mixed numbers to improper fractions. We have 37 holes. Each hole is divided into 2 parts, so we multiply times 2, plus 1 more part, divided by the 2 parts that our holes are divided into. 37 times 2 is 74, plus 1 is 75 over 2. And then change 1 1/4 to an improper fraction. We have 1 hole. Our whole is divided into 4 parts, so we multiply times 4, plus 1 more part, divided by our 4 parts. 1 times 4 is 4, plus 1 is 5, divided by our 4 parts. So 1 1/4 is the same thing as 5/4. Our rule for division says we bring down the first fraction, we change division to multiplication, and we write the reciprocal of the second fraction. In other words, we invert and multiply. I like to simplify before I multiply. Remember, we can only simplify from top to bottom. 2 goes into itself 1 time, and 2 goes into 4 2 times. 5 goes into itself 1 time, and 5 goes into 75 15 times. Multiply the numerators. 15 times 2 is 30. Multiply the denominators. 1 times 1 is 1. And 30 over 1 is 30, so we can place 30 books on the shelves. When we're trying to estimate or use mental math with rational numbers, we can use some of the same strategies that we talked about with our whole numbers. Example 13 asks us to compute each of the following mentally. Now, I'm going to show the steps And on a show work problem, you would have to show these steps as well, or steps similar to this. But these steps would be done in your head. As I look at part A, I can figure out pretty quickly what 12 times 1/4 is. So the first thing I'm going to do is use my commutative property and change the order. So rather than 12 times 25, I say 25 times 12. I also know that I can change the grouping when I multiply, and it doesn't change my result. That's our associative property. So rather than grouping 25 and 12, I'm going to group 12 and 1/4. Then 12 times 1/4 is 3, and 25 times 3 is 75. Look at part B. In my head, I'm going to think to myself that 5 and 1/6 is the same thing as 5 plus 1/6. I'm going to distribute the 12 in my head, so I have 5 times 12 and 1/6 times 12. 5 times 12 is 60, and 1/6 times 12 is 2, so that gives me 62. Part C. 4 over 5 I can write as 4 times 1/5. I chose to write this as 4 times 1/5 because I know 1/5 times 20 is a fairly easy multiplication. So I'm going to group the 1/5 and the 20 next. 1/5 times 20 is 4, and 4 times 4 is 16. Now let's look at estimation. I can round 3 and 1/4 to 3. I can round 7 and 8/9 to 8, and 3 times 8 is 24. So that is an estimate for my problem. In part B, I see I have 24 and 5/7 divided by 4 and 1/8. I want to round to numbers that divide easily. So I'm going to round 24 and 5/7 to 24. Round 4 and 1/8 to 4, and 24 divided by 4 is 6. Last, we have our properties of exponents. These apply to our rational numbers as well. Notice we're dealing with non-zero rational numbers, and our powers m and n are going to represent integers. Any non-zero rational number to the 0 power is 1. If I have a negative exponent, such as part B, I move the base and the exponent to the denominator to get rid of that negative exponent. In part C, when I have like bases, I add my powers. In D, when I'm dividing like bases, I subtract the powers. For E, a power to a power, we multiply the powers. In F, notice we have a fraction raised to a power. That means the numerator is raised to that power as well as that denominator. In part G, we have a fraction to a negative power. To get rid of the negative power, we can flip the fraction. And in part H, when I multiply two things and I raise their product to the power, I can raise each factor to that power. So let's look at some examples. We want to write our answers here without using negative exponents. I want to try to get like bases, if at all possible, for each of these. I have 16 squared times 8 to the negative 3 in part A. Well, 16 is 2 times 2 times 2 times 2. That's 2 to the 4th. So I can rewrite 16 as 2 to the 4th. Now don't forget about that squared power that was originally with the 16. Then 8 is 2 times 2 times 2, or 2 to the 3rd. Don't forget about that negative 3 power that was originally with the 8. A power to a power we multiply, so I'd have 2 to the 8th, and then power to a power we multiply, that would give me 2 to the negative 9. My bases are alike, so I add my powers. 8 plus negative 9 is negative 1. And to get rid of that negative power, I move the 2 to the denominator, and my answer is 1/2. Look at part B. We have 20 squared divided by 2 to the 4th. Again, if at all possible, I want to try to get like bases. Well, 20 I can rewrite as 4 times 5, and 4 I can rewrite as 2 squared. A power to a power I multiply, so I'd have 2 to the 4th. The 5 also gets that squared power, And since I'm going to divide, I'm going to write this as a fraction with that 2 to the 4th in the denominator. My 2 to the 4th will cancel out because one's on top and one's on bottom. I'm left with 5 squared, or 25. Look at part C. Here we need to distribute the 10 to the 3rd to each term. So I'm going to distribute 10 to the 3rd to 10 to the negative 1. That means I'm multiplying. I have like bases, so I add my powers. Negative 1 plus 3 is 2, so I'd have 10 squared. Then distribute 10 to the 3rd to the next term. When I multiply the like bases, the 10s, I'm going to add the powers. Bring down the 5 and add your powers of the 10. That would give us 10 to the 1st. Then distribute to the last term. So we have 3 times. Multiply your 10s together. Negative 3 plus 3 gives us 10 to the 0. 10 squared is 100. 5 times 10 to the 1st, or 5 times 10 is 50. And any number other than 0 to the 0 power is going to be 1. So 10 to the 0 power is 1, and that gives me 3 times 1, or 3. 100 plus 50 plus 3 is 153. Then last in part D, we have powers to powers, so we multiply the powers. 3 times negative 4 gives us a negative 12 power for the x. For the y, we have a power of negative 2. We're raising it to the negative 4, so we multiply those two powers together. Negative 2 times negative 4 is 8 for our power. To get rid of the negative power on the x, I bring the x to the denominator, and that power becomes positive. And so our answer is y to the 8th over x to the 12th.